We're going to look at multiplying and dividing real numbers. So when multiplying and dividing real numbers, we're also going to look at exponents, the reciprocals of numbers, what happens when we're dividing by 0 or 0 divided by a number, and evaluating expressions. So really what's important here is understanding what is the sign. Just like when you're adding and subtracting, what's the sign when you're adding a positive with a negative? If it's bigger, the negative is bigger than the positive, you know, those kind of relationships. Same with multiplying, you want to make sure you know the sign. So if you're doing a positive times a positive, you get a positive. If you are doing a negative times a positive, you get a negative. Same thing flipped around, positive times a negative. Doesn't matter the order, it's still going to be negative. And then finally, negative times a negative, you are going to get a positive. So knowing that is really the key to multiplying and dividing real numbers. Multiplying has the same rules as dividing. So let's just go through these examples. Negative 4 times negative 2. Negative times a negative is a positive. 4 times 2 is 8. So we get a positive 8. Positive times a negative for 10 times negative 2. Positive times a negative is negative. 10 times 2 is 20. So negative 20. And then the product of 1, any number times itself, or any number times 1 is itself. So 745 times 1 is 745. But since it's positive 745 times negative 1, it would be negative 745. So any number times 1 would get you back that number. So a times 1 is equal to a. Any number times itself. Do I keep saying itself? Any number times 1 gives you back that number. And then number 4, a whole lot of numbers. Negative 439 times negative 231 times 0 times 34 times negative 300, 738. Keep flipping the numbers. A lot of numbers being multiplied, but look, 0 is present. Any number times 0 is going to be 0. So even if we have 100 million thousand numbers being multiplied together, if one of those numbers is 0, the entire product is 0. So any number times 0 is 0. A times 0 is 0. And then we have negative 3 times negative 10 minus negative 2 times negative 4. So negative 3 times negative 10, negative times a negative is a positive. 3 times 10 is 30 minus negative 2 times negative 4, that's negative times a negative, which is also a positive. 2 times 4 is 8. So 30 minus 8. Careful there. So this became 30. Negative 3 times negative 10. Negative times a negative is a positive. Positive 30. Minus 2 times 4 is 8. So 30 minus 8 is 22. Number 6, we have 3 numbers being multiplied together. Really you want to make sure you understand the signs here of what that's going to end up being. Because you could just do 6 times 2 times 4. And then even if you had a bunch of other numbers, you could just multiply all the numbers. But just know the sign. So let's do the signs first. Negative times a negative is a positive. And then we have times that negative. So positive times a negative is a negative. If we threw in another negative here, just say it's like negative 2. What's going to happen? That's going to be a negative times a negative now, making that a positive. Notice the number of negatives. 4 negatives being multiplied together, an even number of negatives being multiplied together, gives us a positive. Where if an odd number of negatives, so like we have here, because we have 3 negatives being multiplied, negative times a negative is a negative, and then we want to multiply by, negative times a negative is a positive. Negative times a negative is a positive, then we want to multiply it by another negative, making that negative. So if we had 5 negatives, what would the sign be? Negative. If we had 6 negatives, what would the sign be there? Positive. Because if we tack on this extra negative, this is positive, positive times a positive is a positive. So the even number of negatives, not just the even number of digits, like if this was just positive 2, that would still be a negative sign in the end because it's negative, 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 positive. So these two terms would be positive, still times a negative, which is negative, and then it'd end up being a negative times a positive because that's a positive 2. So you still get negative. So it's not the number of digits that you're multiplying or anything like that. It's the number of negatives that you'd end up multiplying to get that sign. So we know the answer is going to be negative because this was positive times a negative 4. So we know the answer is going to be negative. So now we just do 6 times 2, which is 12. 12 times 4 is 48. So we get negative 48. Negative times a positive is negative, so that's going to be 9 times 3, which is 27, times negative 1. Negative times a negative is a positive. 27 times 1 is 27. Exponents. Big topic here, exponents. So when looking at exponents, an exponent tells us how many times we multiply the number together. So if I have a to the third, that is a times a times a. If I have a to the fifth, a times 5 times. A to the 100th, a being multiplied 100 times. So that exponent tells us how many times we multiply the number together. So on number 8, negative 3 to the third would be negative 3 times negative 3 times negative 3. Now I want to compare that directly to number 9, negative 3 to the third. This is negative times 3 times 3 times 3. It's 3 being multiplied 3 times together, and then that negative's on the outside. Where on number 8, it's negative 3 being raised to the third power. So it's negative 8 times am I saying negative 8? Negative 3 times negative 3 times negative 3. It's 3 being multiplied 3 times. So that's going to be negative times a negative is a positive. 3 times 3 is 9. 9 times negative 3 is negative 27. So 9 times negative 3, negative 27. So negative 3 to the third power is negative 27. Where compared to here, negative 3 to the third, that's 3 times 3 times 3, which is still 27. But the answer is going to be negative, not for the same reasons as number 8. Those are two different problems. So you could accidentally get this answer correct, not even understanding it. But when the power is even, just like how we are talking about over here with these examples, remember I was explaining negative and negative and negative, what's the sign going to be? That's really important with even exponents. Because on number 10, this is negative 3 to the second power, so it's negative 3 times negative 3. It's negative 3 being multiplied 2 times. Where here on number 11, it's negative times 3 squared. So this is negative 3 times 3. And if you have a TI-30 calculator, or really any calculator, but if you have a calculator like this, and you type in this number, like if you just go to your calculator and you type in negative 3 squared, and you're trying to evaluate this one, you're trying to evaluate parentheses negative 3 squared, but you don't type in parentheses, it's going to do this. It's going to do negative 3 squared because your calculator thinks you're doing order of operations. It thinks you're doing 3 squared, which is 9, and then you want to multiply by a negative. So your calculator is going to spit back negative 9. But you're like, wait, I thought I wanted it to do this. You have to use parentheses in the calculator if you want it to do parentheses negative 3 squared. And there are parentheses on your calculator right above the 8 and 9 if you have a TI-30, just like this. Right above the 8 and 9, there's a parentheses. So the parentheses, negative 3, parentheses, squared, done. And that's going to give you negative 3 times negative 3, which is a positive 9. Negative times a negative is a positive. So positive 9. And you can see the answers are different because of that whole concept of the parentheses, as I've explained. So number 11 is negative 9 because it's only 3 squared. That's definitely something you want to keep practicing. Reciprocals are multiplicative inverses. Two numbers whose product is 1 is a reciprocal of one another. So if we have 22, what would be the reciprocal of 22? We want a number that if I multiply it together, it will get us 1. So what would that number be? It would be 1 over 22. Because 1 over 22, 22 over 22 is 1, so we just get back 1. So the reciprocal of 22 is 1 over 22. Because the product of 1 over 22 times 22 will get us back 1. Number 13, 4 over 15 times what would get us 1? 15 over 4. 15's cancel, 4's cancel, you get 1. So the reciprocal is flipping that fraction. So on number 12, the fraction was 22 over 1. So the reciprocal would be 1 over 22. Number 13, 4 over 15. Reciprocal would be 15 over 4. Number 14, negative 9 over 1. The reciprocal is still going to be 1 over negative 9. You keep that negative there because you want the product to equal 1. And if I drop the negative, I'm not going to get a positive 1. I'm going to get a negative 1. So that's why I want to make sure you keep it negative because 9 over 9 is 0. 9 over 9 is 1. Then 1 over 1 is 1. Negative over negative is a positive, so you get positive 1. And I think number 15 is getting a little close to my camera. So let me do 15 here. So the reciprocal of negative 2/3 Sorry, I didn't even write down the answer from 14. So the answer there was 1 over negative 9. So 15, the reciprocal would be 3 over negative 2. 3's cancel, 2's cancel, negative over negative is a positive, that's 1. So the answer to number 15 would be negative 3 over 2. The location of the negative doesn't matter. Negative on top, negative on bottom, negative in the front, does not matter at all, the location of that negative, just not on both top and bottom. And last topic is dividing, and then dividing by 0, and then we're going to evaluate some expressions here. So dividing, same rules as multiplying. If you're dividing a negative into a positive, that's a negative. Dividing a negative into a negative, that's a positive, and so on. So 16, negative 24 divided by 4. Negative divided by a positive is negative. 24 divided by 4 is 6, so we get negative 6. 17, negative divided by a negative is a positive. 18 divided by 3 is 6. So negative over negative is a positive. 18 over 3 is 6. 18 positive over negative is a negative. 14 divided by 7 is 2. So negative 2. 0 as a divisor or dividend. So meaning, what's the answer when we have 0 divided by 5? And then what's the answer when we have 5 divided by 0? The answer for 0 divided by 5, so 0 divided by any number is always 0. 0 divided by any number is always 0. Then 5 divided by 0 is going to be undefined. And you've probably seen this before, like messing around with your calculator. Like maybe you've just been bored in class or something, and you've just been hitting buttons, and you just type in something divided by 0, and it gives you like some divide by 0 error. That's undefined. Cannot divide by 0. So if 0 is underneath your fraction bar, underneath, undefined, the answer is undefined. Underneath, undefined. So 19, 2 divided by 0, 0 is underneath the fraction bar, so it's undefined. Number 20, 0 divided by 9, 0 divided by any number is 0. Number 21, 0 times negative 2 is 0. 0 divided by 6, 0 divided by any number is 0. Number 22, 8 divided by 7 times 0. So we have 8 on top. 7 times 0 on the bottom is 0. 8 divided by 0. 0 is underneath. So that's going to be undefined again. So if 0 is in the denominator, it is underneath the fraction bar, it is undefined. Last topic for this video is evaluating expressions. X equals negative 3, y is equal to negative 4. So let's go ahead and take a look at these. So 23, we have 4x, that is representing 4 times the x value of negative 3, minus 7 times the y value of negative 4. 4 times negative 3 is negative 12. You could do this two different ways. You could say minus and then do 7 times negative 4. 7 times negative 4 is going to be negative 28, because 7 times 4 is 28, and then 7 times a negative, or positive times a negative is a negative. Or you could think of this as negative 7 times negative 4. Either way, you're going to get negative 12 plus 28, because negative 7 times negative 4, negative times negative is a positive. 7 times 4 is 28. So you could do it like that. Or you can just do it as minus a negative 28, minus a negative. Opposite of negative 28 is positive. So it doesn't matter. Either way, you're going to get 28 plus negative 12, or negative 12 plus 28. 28 minus 12 is 16. Positive 16. 28 minus 12. 24, making sure we understand exponent rules. So this is x to the third minus y squared. So the x value of negative 3 to the third power minus the y value of negative 4 to the second power. Negative 3 to the third power is negative 3 times negative 3 times negative 3. So negative 3 is being multiplied 3 times. We looked at this earlier. Now the x value is in parentheses because I'm evaluating whatever x is equal to the third power. Let's just say x was equal to like x minus 5. What we would write this as x minus 5 being raised to the third power. Parentheses around x minus 5 because x minus 5 wants to be raised to the power. So even if it's just a singular number, this could be negative 3 to the third power, which we already talked about. That's negative 27. Minus negative 4 squared. That's negative 4 in parentheses because, again, the y is being squared. So negative 4 times negative 4 is positive 16. And we still have this minus sign here Because this was minus the y value squared. So we're doing a separate evaluation there. Y value squared would be y squared, and then we want to subtract that off. So now we have negative 27 minus 16, which is going to be negative 27 plus a negative 16. So because we have negative 27 and we want to go further in the negative direction, so negative 27 plus a negative 16 is negative 43. So there's negative 43. Last one, 3x squared minus 11. So that's going to be 3 times the x value of negative 3 squared minus 11 over y squared, so negative 4 squared. Evaluate the exponents. So same thing I've been talking about. Negative 3 squared is in parentheses, so that's negative 3 times negative 3. That's going to be 3 times 9 minus 11 over negative 4 squared. Negative 4 times negative 4 is positive 16. 3 times 9 is 27 minus 11 over 16. 27 minus 11 is 16 over 16. 16 over 16 is 1. There's a good set of problems there. And the key, if there's anything I want you to take from this video, is this. X squared, y squared, you're putting those in parentheses because you want to evaluate the entire x to the second power, or the entire y to the second power. So that needs to be parentheses, and that's different than this. Very, very different.